Okay, in this section, we're going to talk a lot about what's called integration by parts. It's this really cool way to integrate, but it's also a little bit tricky because you've got to really sort through kind of what's going on and pick certain things, and it can be a tough little guy. But basically, it's the product rule in reverse is what we're doing. Is we're kind of undoing the product rule here. So, and remember, product rule says if we've got like if we have f of x equals u times v, then what we have is u times v prime plus v times u prime. Okay, that's your product rule. And so what we're going to do with our product rules, we're going to set up and this is called integration by parts. We're going to pick two things. We're going to pick something to be u, and we're going to pick something to be dv. And when we do that, we follow this pattern on the right-hand side of the equal. We're going to follow this pattern right here. Okay, so let's go ahead and give this a try. And this is all pattern-based stuff. So if you don't see it the first time around, that's okay. Practice, 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 and it will make perfect. All right, so let's give it a try. X cosine x dx. There's no way that I could set a u substitution up for this and get it to work. If I let u equal x, as we've learned about substitution, when I take that derivative, du dx is equal to 1, multiply both sides by dx, so du is equal to dx. I have dx, but I also have this spare x running around. So my integral would look like this. X, it would look like u cosine u. And this is basically exactly where I started. I can't integrate this. We don't have something, a pattern or anything that this would integrate back to that we know right off the top of our heads. So what we're going to do is we're going to come back here and we're going to we're going to follow this pattern of u dv. Okay? So here we go. Let's let u equal x, and let's let dv equal cosine x dx. Okay? And the reason that we're going to do this is now when I substitute these guys in, this integral becomes the integral of u dv. Okay? And I'm picking these for a very specific reason, and we'll see later why. So I've got u times dv. So what do I need to do? I've got to get u times v. Well, I don't have v. I've got dv. So integrate this one. And v becomes, when you integrate cosine x, you get sine x. Okay. So here's u times v. All right. That's this part of my equation. So I've got u times v. So here we go. This will be u times v minus the integral. And then I need v du, but I don't have du. So back over here to this guy, take the derivative of both sides. So du dx equals 1 and du equals dx. So now I do v times du. So sine x times x dx. Sine x, that's the wrong color. Okay, so I'm going to have v du right here, sine x times dx. All right, one more step here because I can actually now integrate sine x. And so that's going to give me x sine x minus cosine x plus c, because now we're at the very end of our integration. We've got to add that constant of integration. And if you'll notice right here, if I take derivative of that, I would have to do the product rule because I have one function times another. And so this is really kind of a cool thing to work with, but it can be a little confusing. And by the way, the antiderivative of sine x should be minus cosine. There we go. All right. So this is integration by parts. Some tips for choosing, okay? Some tips for choosing what needs to happen. And I put them right down here for you. All right. Some tips for choosing. Always pick natural log to be your u if that's an option. That wasn't on this first one. Then look for an inverse trig function. We also didn't have one of those. Next, look for any polynomial. That's the x. All right. If there are really no polynomials, look for an exponential function. And then lastly, look for the trig function. Notice that we did not pick trig to be u. Okay. We usually want u to be something that simplifies when we take the derivative. And we want dv to be something that kind of remains workable when we integrate, that doesn't become too horribly nasty. And I'll be honest, it's tough sometimes to pick the right thing. But if you follow this table right here, this tips and tricks for choosing u, you will generally wind up with the correct u and the correct v. Okay, but just like when we learned how to evaluate indefinite integrals, it takes practice. And so integration by parts, it takes practice. But the more you do, the easier it will be.